Full Moon Observational Test. A full moon observational test was set up in my garage. A 15,000 lumen LED work light was used to represent the sun. A 10-inch diameter foam ball painted matte deep gray was used to represent the moon and the moon's surface color. The LED work light was placed on a table approximately 15 feet away from the gray 10-inch diameter foam ball. In the next two videos, we will observe how the light emanating from the work light reflects off the gray 10-inch diameter foam ball representing the moon. The LED work light is on and emanating its light onto the 10-inch diameter foam ball representing the moon. It was a breezy night which caused the foam ball to rotate and swing throughout the observational test. Before zooming in on the foam ball, we observe a small center area of the ball is reflecting light at a brighter intensity than the rest of the ball. The color of the intensity of the reflected light in the center of the ball is white because the work light incident rays are hitting the ball's curved surface tangent line and the reflected rays bounce straight back to the camera's observation point. As the work light incident rays hit the ball's curved surface from the center and out to the perimeter edge of the ball, the intensity of the reflected rays is less. This is because the ball's curved surface tangent lines reflect the rays farther away from the camera's observation point. In this video, we observe the same characteristics of the reflected light rays on the ball's curved surface. The intensity of the reflected rays are brighter in the center of the ball and lesser out to the perimeter edge of the ball. We observe the intensity of the reflected light rays are not the same across the surface of the ball. However, when we observe any full moon, the entire moon surface of the moon has the same brightness level, which tells us the moon is emanating its own light. Based on our observations of the full moon test, we can develop a reflected ray spectrum of the 10-inch diameter foam ball representing the moon using the light reflectance value chart. We see three light reflectance colors across the ball: 100%, 90%, and 80%. This diagram of the circumference of a spherical full moon shows the sun's parallel incident light rays hitting the moon's curved surface. The reflected rays bounce off the moon's surface at the same incident angle as the sun's incident rays along the tangent line on the moon's curved surface. We observe the reflected rays are less intense going from the center of the moon's surface to the outer edge of the moon's surface. Based on our observational test, this is the sun-reflected ray LRV spectrum of a spherical full moon. Again, based on our observational test, this is the sun-reflected ray LRV spectrum of a spherical full moon. Now let's compare our observational test to what we really observed during a real full moon. We observed the light intensity or brightness of the moon is the same from the center of the circle to all along the edge. The diagram next to the picture of a full moon depicts the reason of this being repeatedly observed. The moon is a flat plasma disk. During a full moon, the moon is fully charged or lit and fully emanates its light rays onto Earth. Light emanating from a flat plasma disk moon is repeatedly observable during all moon phases. When the moon is between 100% illumination and 0% illumination, we always observe the light intensity or brightness of the moon is the same across the part of the lit disk, always. Observations of the lit areas of the moon throughout the moon phases. During a full moon, the entire moon disk is lit with the same illumination level. During crescent/gibbous waxing and waning phases, as shown on the previous slide, and on this 29-day lunar cycle, the curved edge of the moon facing the sun is always lit, extending to half the circumference of the moon. The lit areas of the moon disk are all at the same illumination level. The unlit areas of the moon disk are darker and invisible. During a new moon, the entire moon disk is unlit, dark, and invisible. Based on the observations of the full moon test performed, we can conclude the intensity of the reflected light rays on a spherical surface/moon surface are brighter in the center of the sphere and lesser out to the perimeter edge of the sphere. However, when we repeatedly observe a full moon, the intensity and brightness of the moon's light rays are at the same illumination level and therefore are emanating from the moon. As stated in Almighty Yahweh scriptures, the moon is a luminaire/light.